Welcome back, deep divers. We're about to get up close and personal with our insides. That's right, today it's all about the digestive system, that world within a world that's chugging away 24/7, whether we're thinking about it or not.
No kidding. And honestly, most of us don't think about it nearly enough.
Not until something goes wrong.
Exactly.
Well, we're here to change that. We've got a stack of fascinating research to dive into.
Oh yeah, this is going to be good. Buckle up.
Our main guide for this journey is gut, the inside story of our body's most underrated organ. And trust me, the title doesn't even begin to cover it. We're going to be talking about everything from, the obvious stuff like, digestion and poop.
Got to cover the basics.
Oh, absolutely. But then we're going to go way beyond that, into how our guts are tied to our immune system, our moods, even things like allergies, and, well, you'll see. It's mind-blowing.
And what I think is so cool is that the author really starts us off with this very relatable experience. So as a teenager, she started having these weird skin problems.
Oh, yeah?
Yeah, totally out of the blue. After a course of antibiotics, she developed all these skin sores. And of course went to the doctors and they were kind of stumped. Suggested it was maybe stress, typical teenager stuff.
Right.
But she had this hunch. And it's a hunch I think a lot of us have had at some point. What if it's not just on the surface? What if it's something deeper, something going on in my gut?
Yeah, I can totally relate to that. So many times you feel like something's off, but you can't quite put your finger on it.
Exactly. And that's what's so powerful about this story. It sets the stage for realizing just how interconnected everything is inside us and how much we take for granted.
It's like this whole team of tireless workers we never even see.
Absolutely. Your kidneys are filtering blood nonstop. Your lungs are pulling in air, even if you're just vegging out on the couch. It's remarkable.
And it all runs on something like the same amount of energy as a small light bulb.
Crazy efficient, right?
Totally. Okay, so since we're talking about taking things for granted, let's talk about poop.
Okay, let's go there.
We all do it, but we rarely talk about it. And it turns out there's a lot more going on down there than we realize. Like, did you know we have two sphincters?
Well, technically, yes. An internal one and an external one.
Okay, explain that.
So the outer sphincter, that's the one you have conscious control over. The one that listens when your brain says, hold on, not a good time.
Right, like when you're at Great Aunt Bertha's and her bathroom is, well, let's just say it needs an update.
Exactly. But the inner sphincter, that one operates on a whole other level, totally unconscious. It doesn't care about Great Aunt Bertha's decor.
So what's its deal?
It's all about the internal environment. Like, is there a buildup of gas pressure? Is everything flowing as it should? And get this, when waste reaches the inner sphincter, it automatically opens up. Just a tiny bit. Just enough to send a little taster through.
A taster.
Yeah, a little sample of the waste gets sent to a bunch of sensor cells that hang out between the inner and outer sphincters.
Well, hold on. Our butts have taste buds.
Not quite taste buds, but, similar idea. These sensor cells figure out whether it's solid or gas, what the consistency is, and then they send that intel up to your brain.
So that's when we get the signal, hey, bathroom break needed.
Precisely. And that's when your conscious brain takes over. You look around, assess the situation. Are you at a concert, in the middle of a meeting? Social considerations kick in.
Then some people are better at holding it than others.
Oh, absolutely. There's a whole spectrum of responses. Some folks tense up and hold it in. Others, well, they find a solution, maybe not so elegant. But the point is, it's this constant back and forth between your inner world and the outside world. Your gut talking to your brain and your brain figuring out how to respond.
A whole negotiation happening down there.
It really is. Now, speaking of negotiation, how are you sitting right now? I'm serious. Think about it.
Well, I'm sitting in my comfy podcasting chair. Why?
Because for most of human history, we didn't sit to do our business. We squatted.
Ah, the squatty potty. I've heard of those.
More than just a fad, though. It turns out our bodies are actually designed for squatting.
Really?
Think about it. When you sit, there's a kink in your rectal closure mechanism, like a garden hose with a bend in it.
Okay, I'm picturing it.
So everything kind of gets backed up. Your sphincter muscles have to work harder to keep things in.
Makes sense.
But when you squat, that kink straightens out. It's a much more direct route for,
So it's not just about being closer to nature or whatever.
Nope. There's actual science behind it.
Like what?
Well, some Japanese researchers, bless their souls, did these studies where they gave volunteers stuff that would glow under x-rays.
Oh, way!
And then they filmed them doing their business in different positions, sitting, squatting, you name it.
Okay, I'm definitely picturing that.
And guess what? When they squatted, Everything flowed smoothly, straight shot out. But when they sat,
Backed up like a clogged drain.
pretty much.
Hmm.
And, if you look at the bigger picture, it's not just about, how easy it is to go, it's about your health. Well, in cultures where squatting is still the norm, conditions like hemorrhoids, diverticulitis, constipation, they're way less common, like significantly less common. And it makes sense, right? You're putting less pressure on your system when you squat.
And we're talking about a lot of people, right?
Yeah.
Like billions.
Yeah, something like 1.2 billion people squat regularly, and they're not struggling with these issues nearly as much. And it makes you wonder, is it worth it?
What do you mean?
Well, are we causing ourselves unnecessary problems by insisting on sitting just because it seems more civilized? I mean, straining on the toilet can increase the risk of all sorts of things. Varicose veins, even strokes.
Oh, wow. Serious stuff.
It's something to think about. So yeah, maybe those squatty potties aren't so crazy after all.
Food for thought, literally. Okay, so we've covered the back end, literally. What about the front end, where it all begins?
The mouth.
The mouth, right. So much happening there, too.
And for sure, you've got your teeth, your tongue, but let's talk about the unsung heroes. The salivary glands.
Saliva. Isn't it just spit?
So much more than just spit. First of all, did you know we have 4 main pairs of salivary glands?
4? I thought it was just like one big one.
Nope. 4. You've got 2 in your cheeks opposite your upper molars. Feel those little bumps. Those are the parotid papillae.
Oh, so that's what those are. I always thought I'd bitten my cheek or something.
And then you've got 2 more under your tongue, near the lingual frenulum, if you want to get technical. That's a mouthful, literally. But seriously, saliva is amazing stuff. It's not just there to moisten your food. It contains natural painkillers.
Wait, what?
Yeah, opioorphin is one of them. It's a natural pain reliever. And saliva also has bactericidal substances that help keep a healthy balance of bacteria in your mouth.
So our mouths are basically mini ecosystems.
Kind of. You actually need a community of good bacteria in your mouth. They take up space and prevent the bad guys from moving in. That's why you often have bad breath in the morning.
Oh, yeah. Morning breath. Not a good look.
It's because while you're sleeping, your saliva production drops. Less saliva means those microbes can party all night.
Makes sense.
Yeah.
So brush those teeth, people.
Definitely. And floss. Don't forget those tonsils either. They have all these little crypts that can trap food particles.
Those tonsils. Always getting infected when I was a kid.
They're part of your immune system, fighting off those invaders. But those crypts can also contribute to bad breath if things get trapped in there.
Okay, good to know. Now, what about the esophagus? That seems pretty straightforward. Just a tube, right?
You'd think so, but even the esophagus has its quirks. The muscle fibers are arranged in a spiral pattern. Gives it a lot of elasticity, like a coiled spring.
Ah, so it can stretch to accommodate that extra large pizza slice.
Pretty much. And here's a little tip for you. Sitting or standing upright after a big meal can actually help prevent heartburn.
Really?
Yeah, it keeps your esophagus straighter, so the sphincters at each end can close more effectively. Keeps the stomach acid where it belongs.
Good to know. So what about the stomach? Where does that sit exactly?
Higher than you might think. Starts just below your left nipple and goes down to below your right rib cage. So if you're feeling pain lower than that, it's probably not your stomach.
Interesting. So what else happens in the stomach?
Well, for one, it churns a lot, mixes everything up, breaks down the food further. But there's also this thing called Romheld syndrome. Have you heard of that?
Can't say I have.
Well, it's this weird phenomenon where gas builds up in your stomach and actually presses on your heart and the nerves around it.
Whoa, so a stomach issue can affect your heart.
Yep. And it can cause all sorts of symptoms,
Yeah.
dizziness, anxiety, even breathing problems. It's often misdiagnosed because it doesn't seem like a stomach problem at first.
Wow, that's crazy. So after the stomach, where does the food go?
To the small intestine, of course.
The small intestine. Now that's a long and winding road.
You're telling me 10 to 20 feet of twists and turns. Imagine that all coiled up inside you.
That's a lot of intestine.
And the first part of it is surprisingly clean. Not what you might expect, huh? But the really cool thing about the small intestine is its surface area.
Surface area.
Yeah, it's not just a smooth tube. It has all these folds. And on those folds are these tiny finger-like projections called villi.
Okay, I vaguely remember those from biology class.
And each villus has even smaller projections called microvilli, and those are covered in glycocalyxes. It's basically a sticky, sugary coating that helps with nutrient absorption.
So it's like layers upon layers of surface area.
Exactly. And if you were to unfold it all, it would stretch for miles, like 4.5
Wow.
miles.
And all that surface area is for?
Absorbing nutrients. Every bit of goodness from your food gets pulled into those tiny capillaries in the villi.
So it's like a giant sponge soaking it all up.
Pretty much. And then all that nutrient-rich blood goes straight to the liver. It's like a quality control center, filters out anything harmful, stores some energy as glycogen, straight to the heart, gets pumped throughout your body. So that sugar molecule from your morning coffee can literally end up in a skin cell on your hand.
Mind blown. And once it gets there, it gets burned with oxygen, right? To release energy.
Exactly. That's the whole point of energy metabolism, breaking down food molecules for fuel. And, we also inhale nourishment in gaseous form. Oxygen is key. It's a big part of what makes up our body weight.
Who knew breathing was so fattening?
Well, not quite, but it is essential. Okay, let's talk sugar.
Sugar. Uh-oh, here we go.
It's not all bad, but it's about understanding it. So sugar molecules can link together to form carbohydrates, bread, pasta, rice, all that good stuff.
Carbs.
When you eat those carbs, your body breaks them down into individual sugar molecules. Same as if you ate a spoonful of sugar.
But isn't there a difference?
The speed of digestion. Refined sugar, it's already in those small pieces, gets absorbed into your bloodstream super fast. That's why you get that sugar rush.
And then the crash.
Exactly. But complex carbs, like whole grain bread, they take longer to break down. It's a slower, more gradual release of sugar.
So slow and steady wins the race.
When it comes to sugar, absolutely. Now, here's the thing. Your body loves sugar. It's a quick energy source. Your brain rewards you for it.
With those feel-good chemicals.
You got it. But the problem is we're surrounded by sugar these days. It's in almost everything. Our bodies haven't quite caught up with this abundance.
Like we're still programmed for those times when food was scarce.
Precisely. So we overindulge. And what happens to all that extra sugar? Well, your body stores it as glycogen in the liver, or, you guessed it, as fat.
Fat, the enemy.
Not necessarily the enemy, but too much of anything is never a good thing.
So how do we get rid of it?
Exercise.
Yep.
Sustain exercise. You got to burn through those glycogen stores first. That's why it takes at least an hour of good exercise to really start tapping into those fat reserves.
Okay, so no shortcuts. Got
Okay.
it. What about fat itself? How does that get absorbed?
Well, fat's interesting. It can't go directly into your bloodstream from the gut because it's not soluble in water. Like oil and water, they don't mix.
Right.
So fat takes a detour through the lymphatic system.
The lymphatic system. That sounds familiar.
It's like the unsung hero of your circulatory system. Lymphatic vessels run alongside all your blood vessels, even the tiny capillaries in your gut.
Okay, and they do what?
They drain away fluids, and that includes fat droplets. So the fat gets absorbed into these lymphatic vessels and eventually makes its way into your bloodstream that way.
Sneaky. So all fat is bad, right?
Not so fast. There are good fats and bad fats. Good fats, like cold-pressed olive oil, can actually be really beneficial. Studies show it can protect against all sorts of things.
Like what?
Arteriosclerosis, cellular stress, even Alzheimer's. It can even help with fat loss by blocking an enzyme that creates fat from carbs.
So olive oil is basically magic.
Not magic, but pretty close. Just remember, moderation is key. Even good things can be too much if you overdo it. In general, you should aim for about 25 to 30% of your daily calories from fat.
So, like, how much is that in real-world terms?
Well, a Big Mac will set you back about half your daily fat intake. On the other hand, a Subway sandwich is pretty low in fat. Depends what you get, of course.
Got it. Okay, what about protein? This is a big one for vegetarians and vegans.
Absolutely. Plant-based proteins, they're often incomplete, meaning they don't have enough of certain essential amino acids.
Amino acids, those are the building blocks of protein, right?
Exactly. Your body needs all of them to function properly. But plants, they often lack certain ones.
So how do vegetarians get enough protein?
By combining different plant foods, like beans and rice, or pasta with cheese, it's all about finding those complementary proteins that provide all the essential amino acids.
Smart. And there are some plant-based complete proteins, right?
You got it. Soy, quinoa, amaranth. Tofu is a great example. It's a complete protein and super versatile.
So no need to worry about protein deficiency if you're plant-based.
Nope, just got to be mindful about combining your foods. Now, this brings us to allergies.
Allergies. A whole other can of worms.
Well, one theory is that allergies can start in the gut. If proteins aren't fully broken down into their individual amino acids, these little protein particles can get into the lymphatic system.
And then what?
Your immune system sees them as foreign invaders and launches an attack.
Ah, so that's why we have allergic
It's
reactions.
one possible explanation. And it's not just fat-soluble allergens. Sometimes your gut lining can become more permeable, allows things like gluten to pass through.
Gluten, the big bad wolf of the food world.
Well, it depends. For people with celiac disease, gluten is a serious problem. It triggers an immune response that damages the lining of the small intestine.
And that can lead to all sorts of problems, right?
Oh, yeah. Malabsorption of nutrients, digestive issues, even neurological problems. It's a genetic condition, affects about 1 in 100 people.
And then there's gluten sensitivity.
Right, which is more common. People with gluten sensitivity, they react to gluten, but they don't have the same level of intestinal damage as those with celiac.
So how do you know if you have it?
It's tricky. Standard celiac tests come back negative, so it's often diagnosed based on whether symptoms improve on a gluten-free diet.
So it's a bit of a guessing game.
Kind of. It's worth noting that your gut can become temporarily more permeable after things like antibiotics or stress, might experience temporary gluten sensitivity. For celiac, doctors look for these specific DQ markers. If you don't have them, you probably don't have celiac.
Good to know. What about lactose intolerance?
That's not an allergy, it's an enzyme deficiency. People with lactose intolerance don't have enough lactase, which is needed to break down lactose, the sugar in milk.
So milk does a number on them.
Basically, undigested lactose goes to the large intestine, feeds the bacteria there, and they produce a lot of gas, hence the bloating and discomfort.
Not fun. But at least it doesn't damage the gut lining like celiac.
Right. It's generally less harmful. And then there's fructose intolerance. It's the difficulty digesting fruit sugar. There is a severe hereditary form, but more commonly, it's fructose malabsorption.
Fructose malabsorption.
It's when the transporters in your small intestine get overwhelmed by too much fructose. Happens a lot with processed foods.
Ah, those sneaky added sugars again.
And, even people without fructose intolerance, they pass some undigested fructose into the large intestine, especially after eating a lot of it.
So it's all about balance.
Pretty much. Too much of anything can throw things off. And your gut bacteria play a role here too. They feast on that undigested fructose and, well, you know the rest.
Okay, so our guts are clearly doing a lot more than just processing food. It's a whole symphony of activity down there.
Absolutely. And it's all connected. Like, did you know your gut interacts with other senses? Like smell.
Smell.
Yeah, think about it. You smell food, those molecules drift up into your nose, dissolve in mucus, and reach your olfactory nerves.
So we're literally tasting with our noses.
In a way, yes. It helps us assess the food even before we take a bite. And then there's swallowing. That seems simple, but it's a remarkably coordinated process.
You mean like getting the food down the hatch?
Exactly. It's called propulsive peristalsis. It's like a wave moving through your esophagus, pushing the food down.
Yeah.
And it works, even if you're upside down.
Cool party trick.
But seriously, it involves your conscious and unconscious nervous systems working together seamlessly. We even practice swallowing in the womb. It's amazing. And as adults, we do it hundreds of times a day without even thinking about it. It involves over 20 pairs of muscles.
Wow, that's impressive. So what happens in the stomach? Does the food just sit there?
Nope. The stomach churns like a washing machine. It's called retropulsion, helps break down the food even further and also stimulates the rest of your digestive tract. That's why you often feel the urge to go to the bathroom after a big meal.
The post-meal poop. A classic. What about that rumbling belly we get when we're hungry?
That's actually your small intestine, not your stomach. It's the housekeeper at work, cleaning up any leftover bits between meals. But it only happens when both your stomach and small intestine are relatively empty.
So snacking all the time prevents this cleaning process.
Exactly. It's like never giving your gut a break. And this brings us to issues like reflux and heartburn.
Oh yeah, those are no fun.
It's when stomach acid goes up into your esophagus. Basically, the nerves misfire and the acid goes in the wrong direction.
Ouch.
Antacids can help. Even potato juice can offer temporary relief. But you don't want to rely on those long term. Stomach acid is important for digestion and fighting off bad bacteria.
So what do you do?
For short-term relief, there are medications like PPIs, proton pump inhibitors that reduce acid production.
Okay, and then there's vomiting. That's always a good time.
Not exactly pleasant, but it's a protective reflex. It involves your lungs taking a deep breath, your stomach relaxing, and then your diaphragm and abdominal muscles contracting forcefully to expel the contents.
Like a reverse food wave.
Pretty much. It's interesting to note that not all animals can vomit, and that can influence their eating habits and how they deal with toxins. Stress can also trigger vomiting. It's through the release of CRF, a hormone produced in both the brain and the gut,
So our guts and brains are talking to each other.
all the time.
Hmm.
Now, on the other end of the spectrum, we have constipation. That's often a disconnect between the nerves and muscles in your large intestine, especially at the very end.
So it's not just about how often you go.
Right, it's about the difficulty. If it's a struggle, that's constipation. Travel can trigger it, illness, stress.
Ah, yes, the dreaded travel constipation.
It's usually temporary, but if it's persistent, it's worth seeing a doctor to rule out any underlying issues. Staying hydrated is crucial.
Always good advice. What about laxatives?
They can be helpful, but you don't want to get into a cycle of dependence. PEG-based laxatives are generally well tolerated.
Good to know. Okay, let's switch gears for a minute. I wanted to talk about the brain-gut connection.
Oh, that's a fascinating one. Did you know there's this creature called a sea squirt?
The sea squirt.
Yeah, it's this marine animal that actually loses its brain once it settles down in one spot.
What? Why?
Well, it supports this theory that the primary purpose of the brain is to enable movement. Not just physical movement, but also facial expressions, speech, making decisions.
So our brains are all about action.
It seems so. And it makes you think about our own brains, right? They're capable of so much, but your sense of self isn't just in your head.
So where else is it?
Your gut. It has this vast network of nerves. It's constantly sensing your internal state, influencing your subconscious mind.
So our guts are thinking too.
In a way, yes. And that connection between your gut and brain that you have as a baby, it doesn't disappear. It just gets more refined as you grow up.
So a happy gut, happy mind.
Something like that. A healthy gut contributes to a sense of well-being. Researchers are even looking at ways to make the gut-brain barrier less permeable.
Why would you want to do that?
It could help with intestinal problems, but also with stress response. You know, when you're stressed, your brain actually borrows energy from your gut. It's all connected.
Wow, that's wild. And what about those studies with mice?
Oh, you mean the ones where they found that gut bacteria can influence behavior?
Yeah, like making them more timid or more social.
Exactly. It's fascinating stuff. Now, we can't just apply those findings to humans, but it does suggest a powerful link. Good psychotherapy can be seen as a kind of physical therapy for the nerves, easing tension. Hypnotherapy uses guided imagery. It's all about influencing the brain.
So it's not just about our thoughts, it's about our whole being.
Exactly. That theory about the brain's purpose being movement towards a healthy equilibrium makes a lot of sense. We seek food when we're hungry, warmth when we're cold. Maybe we need to broaden Descartes' famous saying, I feel, therefore I think, therefore I am.
I like that. Okay, let's dive into the world of microbes.
Buckle up, it's a wild ride.
I'm ready. So we're talking about bacteria, right? The trillions of them living in our guts.
Trillions is an understatement. From space, humans are invisible, but our microbial inhabitants are everywhere inside us.
Like a whole universe down there.
And it's a diverse one. The immune system in your gut has to tolerate this huge population of bacteria, but also be ready to fight off the bad guys.
How does it tell the difference?
That's the challenge. Some bacteria have surface structures that look very similar to human cells.
So it's easy to get things mixed up.
Exactly. It's why conditions like strep throat need prompt treatment. Otherwise, the immune system might attack your own tissues.
Autoimmune reactions, right?
Yep. And scientists are exploring potential links between gut bacteria disruptions and conditions like type 1 diabetes.
So our guts are basically training grounds for the immune system.
Absolutely. Immune cells have to go through a rigorous boot camp in the gut. They have to learn to recognize and tolerate your own tissues.
Makes sense. What about those germ-free mice?
Oh, those are fascinating. They're raised in completely sterile environments, so they have no gut bacteria at all.
So how are they different from regular mice?
Well, they're hyperactive, they lack caution, they eat more but digest slower. Their appendixes are huge, their digestive tracts are underdeveloped, they have fewer immune cells, and they're super susceptible to pathogens.
Wow, that's a long list.
It shows just how important gut bacteria are. And get this, if you transplant bacteria from other mice, like obese mice, the germ-free mice can actually develop similar traits.
So bacteria can make you fat.
It's more complex than that, but it does suggest a strong influence. Now, our own gut flora starts developing at birth.
From the mother, right?
Well, for babies born vaginally, yes. They get their first dose of bacteria from the birth canal. But for C-section babies, it's different.
They get their bacteria from the hospital environment.
Exactly. And their gut flora develops more slowly. Studies have shown a higher risk of allergies and asthma in C-section babies.
So there's a link between birth method and gut health.
It seems so, but by age 7, gut flora tends to even out. But early life factors can have a lasting impact. Poor nutrition, antibiotics, excessive cleanliness.
So what about adults? Our gut flora is pretty stable, right?
It reaches a stable state around age 3, and it travels with us throughout our lives. But it's constantly changing, influenced by our diet, stress, everything.
So it's like a dynamic ecosystem.
Precisely. And it's a huge one. Your gut flora has 150 times more genes than you do. It's a whole biome. And it reflects your identity.
So our guts are like fingerprints.
In a way, yes. Now, studying the microbiome is incredibly complex, but there was this breakthrough discovery in 2011, the 3 human enterotypes.
Enterotypes.
Basically, they're the dominant types of bacteria in our guts. Bacteroids, Prevotella, and Ruminococcus.
And everyone has one of these.
It seems so, and they might be linked to various characteristics like how you respond to certain foods. Still early days in research, but super interesting.
So what do these enterotypes do?
Well, bacteroids, they seem to be good at extracting energy from meat and fat. Prevotella, they're associated with processing carbs and fiber. And Ruminococcus, they're also involved in carbohydrate digestion.
So different bacteria for different diets.
Yeah, makes sense, right? And our gut bacteria, they do so much for us. Like, did you know they produce vitamin H?
Biotin.
The one and only. Essential for metabolism, healthy skin, hair, nails. It's pretty amazing what these tiny creatures do.
It really is. So it's a two-way street, right? We feed them, they feed us.
Absolutely. It's a mutualistic relationship. They break down stuff we can't digest, and then they share the nutrients with us, like 1 spoon for you, 1 for your bacteroids.
I love that analogy.
It's a good one. It's like they pre-digest food for us. Think about yogurt. It's basically pre-digested milk. The bacteria have broken down the lactose, making it easier for us to digest.
Ah, so that's why yogurt is good for people with lactose intolerance.
Exactly. And they do more than just break down food. They also create new substances. Like sauerkraut has more vitamins than fresh cabbage, thanks to the bacteria.
Really? So fermented foods are good for us.
They can be. They're packed with beneficial bacteria. And bacteria are responsible for the taste and texture of so many things. Cheese, salami, wine. Even the aftertaste of wine is influenced by the bacteria on your tongue.
Wow, so we're basically walking fermentation tanks.
In a way, yes. And it's estimated that our gut bacteria contribute about 10% to our overall nutrition. It's not nothing. And the types of bacteria you have can play a role in weight management.
So can bacteria make you fat?
Well, there are a few theories. Some bacteria are more efficient at extracting calories from food, and some might even influence our metabolism and food cravings. It's like they have their own agenda.
It's like a microscopic battle for control.
Kind of. But there are definitely good bacteria out there. Like there were these early observations of the Maasai people. They have high-fat diets.